Hello everyone. Welcome to my channel Psychology Point. Today we are talking about the psychology of people who avoid eye contact. Let's start. In clinical settings, when a patient routinely avoids meeting an examiner's gaze, the behavior is typically logged as a sign of inattention or deliberate opposition. Standard behavioral therapies interpret this as a social deficit requiring correction. The prevailing logic insists patients must maintain normative eye contact to demonstrate respect or active listening. Functional neuroimaging contradicts the premise of behavioral enforcement. Gaze aversion is an active, mechanical downregulation strategy. It is a neurobiological response executed by the brain to prevent allostatic overload. Understanding the mechanics of this avoidance requires examining two specific data sets: task-based fMRI scans that capture acute threat responses in real time, resting state fMRI maps that reveal a chronic vulnerability at the baseline network level, acute threat responses in autism spectrum disorder (ASD). When the neurological necessity of gaze avoidance is ignored, the resulting pressure can push a patient's nervous system past its physiological limits. We begin with the acute reaction. A study tracking task-based fMRI data placed autistic subjects inside a scanner, instructing them to analyze digital human faces on a monitor. Under natural observation conditions, where the subjects could look wherever they chose, the activation in the amygdala, the brain's primary threat detection center, appeared low. The researchers then introduced a strict mechanical constraint. They required the autistic subjects to fixate directly on the eyes of the faces for the exact same duration as a neurotypical control group. Analytical. This line graph plots fixation time on the x-axis against the amygdala bold signal on the y-axis. When eye contact duration is forced to neurotypical standards, the blood oxygen level dependent signal in the autistic amygdala scales exponentially. The steepness of this curve reflects the intensity of the physiological hyperarousal. The brain registers the prolonged gaze as an acute, escalating threat. By contrast, the neurotypical control group maintains a relatively flat baseline. Their amygdalae are unaffected by the exact same visual exposure. Breaking eye contact immediately shuts off this signal spike. Averting the gaze serves as a mechanical circuit breaker that stops the amygdala from redlining. Treating a physiological regulation tool as a behavioral problem is a misinterpretation of the underlying biology. This threat detection network remains active in the absence of social stimuli. In patients with social anxiety disorder, we see a structural vulnerability even when they are at rest. To map this, researchers utilize resting state functional connectivity, or RSFCN. This modality traces the brain's default wiring, showing us how regions communicate without external prompts. Decoupling. The first structural anomaly is a decoupling. The regulatory pathways connecting the amygdala to the dorsolateral prefrontal cortex are reduced, weakening the brain's natural ability to dampen fear responses. In the absence of prefrontal regulation, aberrant positive connections dominate the resting brain. The most prominent of these is a heightened connection between the amygdala and the fusiform gyrus, the anatomical structure responsible for facial recognition. With the fear center hardwired to the facial recognition area, the brain is hypervigilant to facial expressions, even when alone in a scanner. Heightened interoception. A second pathway forms between the left amygdala and the anterior insula. The insula processes internal physical sensations. This connection creates a state of heightened interoceptive processing, a persistent hyperawareness of internal anxiety. The socially anxious brain at rest is structurally wired to perceive faces as threats and internally amplify that fear, making the act of eye contact inherently overwhelming. This chronic hyperconnectivity extends into the default mode network, the brain system for introspective, stimulus-independent thought. In SAD patients, the left amygdala maintains abnormal positive connections with key hubs of the DMN, specifically the precuneus and the supramarginal gyrus. This topological intrusion floods resting states with what researchers call emotional coloring. Because the DMN handles our internal monologue, this structural hijack means that introspective thought becomes dominated by social evaluative surveillance. A patient cannot simply relax during social interaction when their brain's baseline for introspection is structurally occupied by the fear center. Hemispheric laterality and clinical implications. Quicker, focused tone. To understand why SAD specifically triggers this architecture, we have to look at hemispheric laterality. The left and right sides of the amygdala process threats differently. The right amygdala handles rapid threat detection and habituation. The left specializes in sustained stimulus evaluation. Data from Young et al. Shows that SAD is defined by a left amygdala dominance at rest. This sustained evaluation center maps abnormally strong connections to the inferior frontal gyrus and the interparietal sulcus, or IPS. The IPS is the structure responsible for directing overt visuospatial attention. It controls where we look to interpret the intent of others. This graph plots the strength of left amygdala IPS functional asymmetry against clinical symptom severity scores. The positive correlation on our value of 0.365 links this structural asymmetry directly to the patient's clinical profile. The brain's visual attention network is effectively tethered to its evaluation-focused fear center. Forcing eye contact pushes visual data through a hypersensitive evaluation loop, creating the conditions for a panic response. Neuroimaging defines two distinct mechanisms: acute, stimulus-evoked hyperarousal in ASD and chronic, left lateralized hyperconnectivity in SAD. These mechanisms expose the autonomic double-bind created by traditional clinical expectations. A behavioral demand to maintain normative eye contact directly collides with a neurological reality of allostatic overload. Forcing exposure to social gaze without addressing network topology can cause physiological harm. Treating a physiological threshold as a behavioral refusal ignores the evidence of an over-optimized threat detection architecture. Clinical care must pivot toward neurobiological accommodation, recognizing gaze aversion as a necessary tool for nervous system regulation. Do you struggle with making eye contact, or do you know someone who does? Drop a comment and tell us your experience. Let's finally clear up this misunderstood behavior. Don't forget to like, share, and subscribe my channel. Thank you.